Two ships A and B can establish mutual communication when they are not more than 50 km apart. At midnight, the ship B, moving towards the north with a velocity 4 km per hour, passes a location 80 km east of ship A that is moving with velocity 16 km per hour towards the northeast. Find the time interval during which they were in communication. Okay, so this is question number 31 from the book Pathfinder, chapter kinematics and subsection check your understanding. Two ships A and B, they are 80 kilometers apart. The velocity of B is 4 km per hour moving towards north. Velocity of A is 16 root 2 km per hour, 45-degree angle with the north and east. So it is in the northeast direction. If we resolve this velocity into its components, so we'll have two components of 16 km per hour each in east direction and in north direction, like this. Now, if you consider the whole situation with respect to ship A will find the velocity of ship B as 4 km per hour, its own velocity. Ship A will see these two velocities in opposite directions in ship B as well, like this. And ship A will see itself to be at rest. So ship A is at rest, and with respect to A, B will move with a velocity resultant of all these. So 16 and 4, they are just opposite, so they will have a resultant of 12. 12 and 16, they are perpendicular, so they'll have a resultant of 20 in this direction. It will make an angle of 37 degree. You can verify. Drop a perpendicular from A onto this line, and suppose it lands at point E. AB is 80 kilometer. We can find BE, and it will be 80 cos 37, and on solving it will come out equal to 64 kilometer. And similarly, AE will be 80 sine 37, and that will come out 48 kilometers. Now, this circle is a circle of communication. So when ship B comes anywhere in the circle, A and B can communicate. So when B is at this point, uh, call this point as C, communication, it's entering into communication zone. And when it is at D, it is going out of the communication zone. So from C to D, A and B, these two ships can communicate with each other. So we have to find the time from C to D. Suppose EC distance is X. So using this triangle, using Pythagoras theorem in it, we can find X as 14 kilometers. So B to C distance is 64 minus 14, 50 kilometers. And B to D distance will be 64 plus 14. So that will come out equal to 78 kilometers. So now we can easily find the time in which B will cover 50 kilometers and the time in which B will cover 78 kilometers. So time from B to C is a time to cover 50 kilometers with the speed 20 kilometer per hour. So that will come out 2.5 hours, and it can be converted into hours and minutes. So it is 2 hours and 30 minutes. Similarly, time from B to D is 78 kilometer divided by the speed 20 kilometer per hour. So it comes out 3.9 hours, and it can be converted into 3 hours and 54 minutes. So when ship was at this point, B, the time was 12 midnight. At C, the time will be 2 hour and 30 minutes in the morning. And when ship is at D, the time will be 3:54 a.m. Okay, thank you.